Okay, so we are recorded now. Laurentiu, thanks for accepting our invitation, and it's our pleasure to have you with us once again. So I remember your talk 2 years ago, as far as I remember. It was very interesting as well. And we also welcome our participants. I hope that a few more people will join us later during the talk. But I think we can start. So we are also recording this lecture, so the video will be later available to all the participants. So Laurent, if you are ready, we can start, and the Zoom is yours.
Yeah, sure. Thanks, Pavel. Thanks again for inviting me, and good luck to everybody at the hackathon. We hope to see more and more interesting quantum computing projects, games, applications that hopefully are interactive and fun to play with, not just the numerical types and yeah,
Hmm.
where you just play with bracket and so on, but get to do a bit more than that. And I think that's gonna be key for getting people excited about quantum computing and seeing the space actually pick up and become more mainstream, especially now with 2025 being discussed at the UNESCO to be the year of quantum.
Yeah,
So
that's
we
correct.
really hope to see a lot of stuff happening, especially 2 years from now. Speaking of long time scales, right? So Quantum Odyssey has been the project I've been working on full time, literally full time since 2019, since my PhD days.
Hmm.
Uh, I'm lucky and proud to say that, well, since then, this little application software, edtech, computer game, whatever you want to call it, has been funding me to travel around the world to do cool stuff. For example, I'm now in Korea, looking at
Hmm.
how we can translate the game and how we can get some partners so that we can start with Quantum Odyssey, some esport events, hopefully on a big scale in which people compete one against each other to develop quantum algorithms using Quantum
Hmm.
Odyssey. So that's one of the things we are aiming to achieve here. And for that, we didn't just show up in Korea. We were invited by the Korean government to a really nice program called Korean Startup Grand Challenge. So
Hmm.
yeah, if you take your project above the hackathon and continue working on it, hope to see you here too in the next
All right.
edition. It's like a competition between different companies doing weird, interesting stuff, super different one from another. Yeah, and we are competing who's making like the most coolest, let's see, like yeah, progress, yeah, and
Hmm.
software, usually tech related stuff. So, Quantum Odyssey, what you see here, the version that maybe some of you are familiar with it already, uh,
Hmm.
this is not a public version.
Hmm.
And even if this is not a public version, the other version that I want to show you, this is also another that's not public yet, because we want to really take it to the next level. So for those of you who don't know, let me show you quickly how Quantum Odyssey works, and then I'll explain like what's the plan behind it. So it is quantum phenomena visualizer, you can call it. It visualizes the SO2 group, linear algebra, complex numbers, uh, quite simply, really. It's simple. So if you know the X gates and S gates, you will see this ball cycling from being blue, which is yeah, well, all the negative and positive parts of a real number or an imaginary number, right? So you have four colors. The four colors determine the minus of the positive or the negative value of the complex number. And uh, then all the interactions that you see between bits, it's following the least significant bit method. So from 00 all the way to 1, you have an input here and you have an output here. And everything you do, all the gates you place, you get to see the full Hilbert space in real time as you place it. Just like what's great about it, right? So and then we go beyond that. You can do fancy stuff. So for instance, yeah, you can break the Clifford set. You have some nice explosions. Yeah. So in a nutshell, this is what it does. This is the core value of the product, the fact that you can visualize the full filter of quantum computing. So this can become another gate. It's test. So if you remember this weird allocation of quantum states, uh, this is again showing up. Yeah, it's like this. Yeah, and of course we kind of went beyond that. We constantly look like at what could make it more interesting. What kind of new stuff we can do with it. So for instance, we can yeah, still have some things going on. For instance, we sandwich all the custom gates. So this is a custom gate that I created, which is based on the algorithm that was before here. And uh, this gate is sandwiched in swap operators. So this means you can play around with the values of the matrix however you want. You can change the gate, change the shape, and you can do other things like create U-tree gates using the typical Bloxfield notation. You can run your circuits on the IBM diskette simulator when it's working, apparently not now. And you can save this as a diskette file. And this is where the part that's more edtechy comes in play because we are now designing learning modules a bit different than the ones that you have on the official website for Quantum Odyssey. The learning modules themselves, we received, I think we have like 2,000 something points of feedback. Some of them are quite lengthy and very useful. And the learning modules take you from playing with bits, so playing with simple X gates, not operators, understanding how bits, inputs and outputs, what the problem, how a problem works, what's the quantum circuit and so on, all the way to eigenvectors, eigenstates, how to do all sorts of interesting operators. And also beyond that, beyond like the typical swap operator, W states, stuff that's interesting in communication and so on. We also have right now a Grover search, on real world prompts, teaches you how to encode, how to think about working a problem on a quantum computer. This is usually a field that's you don't really see uh, that you don't get to have many tutorials about this, let's say, on the internet. And it might be, at least from what I know, I'm not familiar with another software that takes you through literally step by step, hand guides you how to build a quantum algorithms. So it teaches you how to think about it, how to go through all the steps about, right, okay, how do I construct Grover? What's a diffusion operator? Can I think of a more specialized version of a diffusion operator? Can I use the diffusion operator in another problem? So it really goes in depth into how you can do quantum algorithms, how you can actually think about creating your own quantum algorithms, which is what the tool is specialized for. So yeah, we also will put a lot of effort into the community. This is a place where we hope to see a lot of activity in the future. Right now, we kind of locked it. We only allowed a single player from our Discord server to create challenges, and he created some really intense challenges. So for those of you who haven't tried it, yeah, you should definitely have a go. I can barely complete them. So there are some problems that are ridiculously hard. There can be, let's say, optimization problems created by some of our players that I it took me like 4 hours to complete one. So yeah, some really good stuff here and better stuff to come. Um, yeah, so this is the second unofficial version. Again, we will put a lot of effort into creating the whole esports competitive element in the game. So I'm not even the best player. Yeah, there are some really good people there
Hmm.
of all genders, which is amazing. I we're speaking with a lot of people from the community. Some are Olympiads from high schools, people who are the best in the world at physics and so on. I'm happy to have them on the server. We also have people who are working at IBM or working in actually in the industry who are playing, and they are not the best on the server. You don't usually get the best and the ones who actually solve the most challenges. People who like puzzle games. They are really, really good at solving all sorts of kind of like optimization problems, like state composition problems that we have in quantum analysis. So yeah, I mean, the learning modules are separated in 3 chapters, and this will change completely. Um, we are working on a new version. So this is kind of like legacy content right now with fundamental rules, applied algorithms, thought experiments, and so on. The new version will be, let's say, more Duolingo style. So the lessons will not be so exhaustive and, well, long as they are now, taking about 1 hour, maybe 2 hours, maybe 3 hours to complete one lesson. They will be split in small, very precise, and very on point lessons of maximum 10 minutes, followed by many challenges. And on top of that, we will also have a story. The next version of Quantum Odyssey will put everything into a universe. The universe with a story will motivate why this is needed, why is this interesting. And we hope to tackle a lot of quantum algorithms. So we're gonna go all over the place, from Fourier transforms to whatever else we can find in the quantum zoo and beyond that, and yeah, even new stuff that you don't get anywhere else. And all of that would be motivated by a story. You really want to captivate the player, to have the player immersed in this world, and give a sense of purpose. So even if the quantum hardware is not here, even if okay, maybe they're lacking the proper certificates or deeper understanding into quantum computing, we hope to create Quantum Odyssey, a place where people can just feel like they're actually doing something interesting scientifically, and at the same time really having fun. I'm happy to say that people are seeming to be having fun. So we've seen people saying the game is very addictive, which is fantastic. So we just finished some hackathons, and uh, we finished looking at the database, what people comment, what people say, because we track all of that. So each time you solve and you finish a lesson, you can give us feedback, right? Because we need to pay close attention to what people say. So I think any good product can only get better if you're actually looking at what people say. If you're just making it for yourself, I don't think there's much future in that. So our focus right now is, yeah, try to tackle all these points. So pay close attention to what people say. Uh, yeah, we've seen professors complaining that you wanted to use the software in school, but it's too addictive, and they should we should include a warning message.
Oh,
Imagine that. It's just out of this
nice.
world. Yeah, like really long comment, really lengthy, like properly motivated with bullet points. Yeah, yeah. So we'll just make it a lot better. Literally, we're now working with professional game developers. A company from Finland called Mytel is helping us. Other people from the industry are also collaborating with us to design quantum circuits. Hopefully, we're also going to have some AI lessons. We'll be teaching
Hmm.
some basics for neural nets, hopefully, and problems like from finance. We want to discuss some problems, like quoting problems from finance. Hopefully, we're just doing a proof of concept up to 5 qubits, but at least discuss a whole idea of how would you go about looking at this problem from a quantum, quantum computational perspective, right? It's usually a bit different than doing it classically. Yeah, so this is the version that we had some hackathons with. So that's that. And I want to show you now how the actual latest version looks like. And yeah, just to give you a glimpse on how much work went into this project. If my source tree is open, let's see. Change this. So yeah, this is the project started. I think this branch in particular started 23rd September 2019. It's been 4 years, and well, the updates kept happening. So, yeah, for that thing. Um, yeah. So, what some of the big changes we're looking at is to um, we do some polishing on the interface. We want to kind of like create some setting for it. Yeah, let me show you an interesting change that we've just finished implementing. I'm quite hyped about it. And we are thinking about how to take it to the next level. So when, let's say I closed this, I found a solution, right? So I'm getting the script already displayed in front of me, which is, well, it's open cast, and it kind of gives a perfectly ready to be put on an IBM machine script. So we are thinking, how can we take this and actually connect it with the real world a bit more? As then you are coding, and as you're coding, the gates are being placed, or the other way around. So you see in real time. So, for example, I place each gate, and yeah, some stuff is happening, and code is being written. So I can in real time see the hit the space, and at the same time create code, or the other way around. This is one of the features that I'm right now looking at if we can have it implemented. And besides that, we will get things a bit more connected with the mathematics, right? So let me make a PDA here. Okay, cool. Yeah, so now you actually see the state of the actual amplitude behind each state. So if you think this as a cat, 00011011, this is the amplitude, the complex number defining the amplitude in the state vector. And so now you can actually look at the poles, look at the whole thing. So there's not going to be any more mystery about like, well, what's happening here. I think we've passed that stage, and we hope to make things very obvious that, okay, you're seeing the full Hilbert space, you're playing with gates. As you're playing with gates, you're creating code, and what's happening in the back is mathematics being run. So these are state vectors. Everything should be very obvious, very easy to wrap your head around, okay, what's happening in this application to run you to it. And yeah, somehow try to grab the code and get people to be stuck with the code. So that's one of the key things I'm looking at. Mm. Yeah, I mean, so in a nutshell, this is the project. Um, a lot of time and effort and energy was being put into it. People who are very excited to work on it and who believe in the potential it can have to bring new people in the field and get them excited about quantum computation without knowing anything. So that's the main core principle behind quantum odysseys. Well, you don't know anything about quantum computing, you think it's cool. You could go try to learn the mathematics, but that could not stimulate you in the right way or enough. And quantum odyssey is not necessarily an alternative. It can be something in parallel to that. Show that the mathematics is super beautiful, that the mathematics has a one-to-one correspondence with art. Yeah, so kind of like you can actually see the mathematics evolving in front of you as you're playing with them. And yeah, that kind of, in a nutshell, defines quantum odyssey. And for professors, we are looking at discovering how we should go best with creating giving them a space where they can create sessions for the students. We've seen it. We've seen that this is a feature very nice in hackathons. So we can have like time challenges. We can have challenges that open at different dates and they close at different dates, and we can see in real time the metrics behind the people who've completed these challenges. Yeah. So 572 gates placed, 14 out of the 19 puzzles solved, 1 hour, 30 minutes. And if you export the files or preview the solution, you get all the statistics. And if you preview the solution, you see in real time what was the solution that the student came up with. So we hope to double down on this feature and hopefully at some point have people discuss why some choices were made, have some events in which some physicists are discussing why certain combination of gates were selected and not the other during competitions. Yeah, and for professors, we hope to give them a space where they can give some tasks like homeworks or like an exam to the students, and the students can just, so these are just sessions I made. All users, including yourselves, if you have Quantum Odyssey, you can create the sessions and you can open the sessions to your friends. You can give them the ID code, and by introducing the ID code, you start the session. It's on the proper date, and you have access to it. So yeah, we've seen there are some universities who are using Quantum Odyssey to teach quantum algorithm design. It's very nice for computer science classes. And we know one professor who is actually grading students. So if they finish all the content in Quantum Odyssey, they get maximum grade.
Is it in the high school or at the university?
University masters.
Yes, masters.
Yes,
Okay,
can give
nice.
master.
Mm-hmm.
That's not nice because this means it's ridiculously hard what we've done. So yeah, there are some challenges here that are like very hard, very difficult, and it takes forever. And you really need to at least three, 4 times to go through the stuff to like be able to solve that unless you're extremely
Mm-hmm.
lucky. And we need to remove that, kind of move away from that, make it more streamlined, make the learning curve a lot easier. And
Mm-hmm.
what is happening is we've successfully secured a 17 million grant together with 20 universities in Europe to do
Mm-hmm.
DGQ.
Mm-hmm.
This is a really nice project in which, well, if you're interested in doing a master's in uh, the specialization in quantum computing or quantum technologies, in general, we definitely would like to invite you to join, apply to DGQ. Uh, what's the difference? I think the strongest motivator why GQ as a master is absolutely brilliant is, well, besides the fact I know the professors behind it, they're some of the best professors I work with. It's that you will have a lot of mobility. So besides, you get a lot of access. You get access to a lot of tools. So you're not just studying on a whiteboard, right? You don't just see brackets. Some professor sits with the back towards you and writes brackets, and you're supposed to learn quantum computing on a piece of paper. You get the tools, you play with the tools, and the tools are kind of part of the curricula. So everything is very digital. The stuff you get access is top notch to what people are doing, and a lot of mobility and the funding for mobility. So I think it's like 6 million or something for student travel. So yeah, you get to be part of different experiences and so on. I think this is one of the coolest projects in Europe for bringing education in quantum technologies to the public, make it more streamlined and have a unified curricula. So hopefully we get 20 universities who have a single or kind of the same type of curricula, which would be nice. But yeah, we'll see if it's gonna happen. Yeah, so in a nutshell, this is more or less what Quantum Odyssey is all about. It's supposed to be a fun, cool place where you can hang out with people. We have a nice Discord server where you're all invited if you have an interest in quantum computing. And here is where, well, we are always present.
Mm-hmm.
And yeah, here's where we make some announcements. We haven't done any announcements for them, I think, I don't know, 1 year or something. But you get some news from people from the outside.
Mm-hmm.
Uh, yeah, we have our tinfoil caps now, and we are just coding, gathering more funding, hopefully doing some partnerships, and just trying to create the momentum for Quantum Odyssey to be adopted as much as possible by a bigger community of people and become kind of mainstream and not just be one of the niche, weird sciencey projects, but find the formula that we can actually pack it as such that we can make it that people don't get scared, because many people are afraid to try quantum software and so on, thinking, oh, it's too hard, it's not for me. But that shouldn't be the case. So that's kind of like a thing we are trying to solve. Make quantum computing seem fun, seem exciting, interesting, create some community and some events, and use the right tone and the atmosphere in it, that you actually feel like you're just having fun and you're doing some science, and science is not boring. So yeah, do join our Discord, and you can always find me here and programmers and other people, and you can always ask us questions. We're always there to answer all type of questions. We also sometimes like discuss, have some interviews or some calls if we have ideas on how to make the experience better and so on. You can always get us, speak with us here. So yeah, I think this is pretty much everything. Yeah.
Okay, great. Thanks. Thank you very much, Laurentiu. Let's see if we have some questions. So I don't see questions on our chat, but maybe some participants would like to unmute and ask. So maybe I can start. How many people, or maybe is this project, is Quantum Odyssey still under active development, or we can say it's okay?
Actually, now
okay. And how
we
many people are involved?
Now, how to say?
Okay.
We are also working with a contractor.
Okay.
It can be 3 people, from 3 to maybe 7, depending on the need. Because
All right.
we are hoping to publish in April, if we're lucky and if we're bug free, to try to create and publish the latest version on Steam and GOG.
That would be great. Okay, and can you maybe tell a bit more about the technology that is behind? So, what kind of technologies did you use for this?
Everything, I think most of the assets and everything is made by us. We've coded everything in Unity. That
Unity.
was our choice because of the ease of portation. Hopefully, we're gonna be able to have mobile versions. We'll also have a Linux, and we now have a Mac version as well that I can send on a request.
Okay, good. And do you maybe count the users? So can you estimate the number of people who have already played it?
Yeah, we know, with 2,400.
Well, that's quite a lot. So yeah, congratulations. So maybe last question from my side. Do you maybe have some advices to our participants of the hackathon? So they have only 1 week left to develop the games or the prototypes of the games. You are in this domain already for several years, so already have some experience. Do you maybe have some advices for them?
Yeah, I think always my favorite advice is, no matter what people say or whatever, if you started working on it and you're committed, then be committed to the end. Don't finish an unfinished project. I think the GitHub is full of unfinished projects. I think 90% of the internet is now just one big unfinished project. So yes, to the end, finish it. Make sure the experience you want is there. It doesn't matter how long it takes. It's your creation, and you should be proud and should go all the way to finish it. Yeah, it doesn't matter. It's just hackathon or beyond hackathon. Just finish.
Perfect. Very good advice. All right, so that's all from my side. Do we have some questions from our participants?
I have a number of questions, actually.
Great.
Okay.
Go on.
So I'm very interested in the design of the game, and especially the design of the user interface, and what you've done to try to make it more accessible to players. One of the issues that I've run into with quantum projects in the past, like when I've done previous jams, is that as the Hilbert space grows exponentially, it becomes too much information to fit on screen and hold in your head at once. I'm curious how you've managed to deal with that for Quantum Odyssey.
So say that again. Too much information on the screen at once.
Because as you add more qubits, you get exponential growth. How do you deal with that exponential growth?
Well, you don't. I
Okay.
mean, if you're not running it on a quantum computer, you will never be able to deal with the exponential growth, right? You always have the limitation. I mean, you cannot simulate quantum computing without exponential plus utilization of your CPU and so on. So what we've done is to limit 5 qubits. Of course, you can do. I mean, we run it on 12 for one project to create an artistic movie. For Christmas, right? But yeah, I mean, this is the reality. Especially if you want to visualize this phenomenon, especially if you care about the, the experience itself. Just imagine if I would have 10 qubits and I would put a gate here. Uh, if I have 10 qubits, it would take about 2 seconds for the animation to play because it is this is what's happening in the back, right? So this gets multiplied, everything gets remultiplied, the state vector is recalculated, all this stuff happens, and it happens in a millisecond, right? And we want the experience to be as good as you can have it. So we deal with it by simply limiting. I think working with constraints is the way to be creative about stuff, I think. And there were more questions. Did I answer? Yeah.
Yeah, that answers my question. And I have a few other questions, but I'll let other people go first.
Do you know I don't know. I'm a big fan of GDC, so I hope everybody who's in the quantum game jam, if you want to make cool stuff, please watch GDC, Game Developer Conference. It's fantastic the stuff you play that. So there was, I think, the thing that inspired me in 2019 was it's a puzzle game if it fits on the screen. If you can put it on a single screen or like in a PowerPoint and as a GIF or something, then you have a puzzle game. You can build it. So you can envision it in a single screen. It's one of those weird design rules. People say, if you take a snapshot, if it's accessible, if the snapshot is somewhat accessible of what it is, what it does, then it can become a good puzzle game. Any more questions? Yeah, so 5 qubits, as you can see, it doesn't look pretty. Yeah, and there is no way around it. Unless we would, I don't know, at some point replace with ZX calculi or something, bring in some new type of, I know, some tensor representation. If you want to go that way, yeah, but I think, I mean, also the core gameplay, that's what should matter, right? So you should think where's your Pareto rule, right? So where is the place where 80% of the time the people will be spending what they will be doing into your application or your game most of the time. So you should always focus, I think, on improving just that. Well, what the core gameplay, the core and the feedback and the drive for you to want to do that more, to want to do that on repeat, to play with that in different ways, right? But what's the core? So once you define the core, and if the core kind of, it can lead to new possibilities. I don't know if you're thinking about Braid or maybe Quantum Odyssey, right? It's kind of like if you think about Braid, that's a puzzle game in which you're walking around and you're playing with time. So I think Newly, right? The designer said so most of the core was that you just want to play with time, right? But as he was designing it, he realized, oh, what if because of this bug that he forgot to adjust for time a ladder? Wow, that's a feature. So it becomes part of the core, and it becomes like something you can do using the core, right? And then what if the enemies would not move when you move, or move in reverse when you move? So stuff like that. Just Braid is just the same principle, reused in different ways, The same as you could argue quantum Odyssey is what eventually. It's literally this, right? Like, wow, look at what I'm doing. You see, it's a million ways. You'd never be bored. It's just, if you like colors, neons and stuff like that, you can do like really cool or crazy or fancy stuff. And what's the beauty behind it is that it is rigorous, right? So this is quantum computations, algorithm building, and you can create whatever patterns you want. So even somebody who doesn't know anything about quantum can still enjoy and do a million different things and go even beyond that. Any other questions? If it's not clear, let me know.
I have another question.
What is this?
I'm curious, did you ever consider adding non-unitary operations like measurement?
Yeah, and I don't like it. So I keep having this discussion. The density matrices, you have the Qiskit simulation. So if you want noise, you have it here. If you want measurement, you have it here. Yeah, it's working. The fun part about designing an algorithm, and that's the core part for me, is getting to know your state vector at the end in its quantum form, knowing the colors too, knowing the difference in amplitude, knowing what you have here and here. This is how I would like this algorithm saved. And I have a reason for that, which is a bit of it's not very public, is that I'm doing also AI research with quantum odyssey. So I'm looking at having a lot of really optimized short algorithms for various problems that we are capturing. So the data is kind of captured about the algorithms that are designed in quantum odyssey, especially when a puzzle is solved and you receive brilliancy points, we store on the server the solution for that problem. And we're kind of looking at it and thinking, is there a way we can build some kind of like stitching all these 4 or 5 qubit quantum gates in such a way that, I don't know, if somebody gives us a mathematical model, would we be able to literally put that in the quantum gate framework and give you the quantum algorithm for it without you having to write code, without having to do anything? And that's kind of like the holy grail of what I think is important right now in quantum. And we are looking for funding for that and to secure some funding at some point. If quantum hardware is going to actually materialize. Yeah, to do research in that direction. Yeah. Any other questions?
Okay.
Hello.
Yes,
Yes.
Hugo. Mm-hmm.
Hello, hello. Congratulations for your game. Very, very, very interesting. I'm very interested about how to you connect the backend. What framework you use to do the quantum circuit? For example, Qiskit or what you use to calculate the gate.
So we could connect it with everything. The question is who wants to pay for it. So it's right now we on our backend we have an SQL server that stores solutions and deals with your challenges and your forms. What where are you? Saves the data, saves how much of the problems you solved, the leaderboard and so on. And now we've only done OpenCast and Qiskit integration. Hopefully others to come, but nobody approached us. Nobody wants that, so then we're not gonna do it, right? Yeah. So if you ask me the strict technical details for our backend, I should bring on the call the backend engineer that we have. Yeah, I did not touch the backend. I only touched the data and building the stuff. That's just design and mathematics and yeah, this was behind. Does this answer your question?
Yeah, sure. Thank you.
Okay. But do feel free to join our Discord. So any questions you have, I can bring the team there and you guys can talk.
Laura, can you maybe also share the link to the Discord here on chat? We can also share it on our Discord.
Yeah. See if I can do this. Yeah.
Okay, great. Thank you. Do we have more questions now, Rory?
Yeah, I have another question.
Great.
This is a very interesting project. Um, I'm curious about specifically part of teaching this user interface to new players. How do you explain to people that the different columns when you place gates on the right correspond to like different strides in the interface on the right?
Yeah,
Or I guess,
I'm very proud with the current explanation. So you can imagine what I showed at the beginning with the narration box in the corner and the nice lady in the UK who reads and reads and reads and reads and basically tells you that this here is your qubit. The qubits are arranged like this. This is an X gate. The X gate works like this and so on. Yeah, well, I really need to change that. I think that's the worst part about quantum Odyssey as it is today. I don't have a good answer yet. All I know is it's gotta be very tight. No more big paragraphs, unending sentences. Very strict, and we've also just now added highlighting. Yeah, maybe that's helpful, right? So when the narration or when a little text appears, um, the element that's being discussed is being highlighted. At least in the new version, yeah, it's gonna be like this. So that should hopefully help. And if that doesn't help, another thing that does is to give space for the people who play it to tell you lots of the features in this version and in the ones who are not released are literally ideas from players because you're just tunneling when you're coding stuff and you don't see any more design, you don't see anything. You go into a rabbit hole of like, oh, I need to make this feature. No, but wait, you haven't finished, doing the basic stuff. So don't make that feature. Do it better. What you already did. So yeah, highlighting and small texts.
All
all
right.
right,
Tooltips.
thanks.
Good. Do we
And
have more questions? Yes, yes.
I'm gonna drop here free quantum odyssey because the version that we have here is new. So this is the newest version, and we need to test it as much as we can. So guys like quantum, guys like games, please test it, play with it, finish it if you can. Let's do some challenges. Send me a challenge ID on Discord. Let's see if I can solve your challenges, and I can send you some of my challenges. Let's do some battles. Yeah, we need to test this a lot. We need to test the servers and get ready for the big release. So yeah, explore with it, enjoy it. Yeah. We want to
Great.
make it a paid project. So yeah, I mean, it's got to be a proper business. You cannot make Quantum Odyssey for free. It has to become a proper business. But from time to time, it should be free. I think this is a good occasion for that.
Fantastic. All right. Do we have more questions?
I mean, I could just keep asking questions.
That's
I've got
fine.
a
We
lot
still
of
have
them.
time.
Yeah,
If
love the
so,
questions. Go ahead.
as long as Laurent is still available for us, that's fine.
Mhm. So part of the reason I'm so interested in Quantum Odyssey is because the project I'm working on for this hackathon is actually somewhat similar to it. I was thinking along another circuit building line and then kind of stumbled across a user interface that I learned just the other day that's very similar to Quantum Odyssey. I'm curious whether there are features or aspects of the program that maybe you've wanted to explore before but have never gotten around to, things that you haven't tried or that you would recommend as interesting areas that I might be able to explore in this hackathon.
Yeah, Everett's many worlds. So if you're doing a circuit visualizer, one of the things I really wanted to go down the rabbit hole before, but it was just too difficult, and yeah, kind of stopped because you had other things to do. Was to be able to have multiple models of these kind of like cards, right? Quantum algorithm design circuits, right? But switch between them and switch measurement axes. So kind of like be able to see z-axis, x-axis, and y-axis at the same time, and see all three at the same time, you know. And
Okay.
think of like, because that opens the whole idea of maybe get people to think about creating algorithms that have multiple solutions in multiple measurement bases if at some point they can be programmed, right? So it's really cool to explore like the whole idea of like seeing it from multiple bases, or yeah, kind of split stuff. That would be cool.
Okay. So this would be like a button that you'd click that would switch you from showing the entire state in the X basis to showing it in the Z basis.
That would be cool. Yeah. Or something that could help you design algorithms with measurement. I really think they should show the average. You know what I mean when I'm saying average, right? So let's say, so if you want to create a game or a tool that actually can have some scientific merit, I think it's important to like. I think this is one of the unlooked at problems. If you can, so let's say you have an amplitude that's 1/3, and this is the 2/3 of the rest. This bit state is 2/3. This one is 1/3. Something that continues with the 1/3, and you can like flip around and like do some new continuation of that, and the one with the 2/3, and then have the whole binary tree of measurements going down and down and down, being able to play with those results further, right? Even post-merit, like I don't know, you can think that the measurement result becomes an ancilla, right? That goes into your new, let's say, card. So you kind of like create a tool that you can combine classical with quantum, like a hybrid algorithm design visualizer tool, something like that. I think that's really cool if somebody can do that.
Okay. And that lets you focus in on specific measurement outcomes and analyze it just post-selecting on that outcome?
Yeah, post-selecting and then being able to treat that like an ancilla and then continue quantum, right?
Mm-hmm.
So like you can imagine like a full adder. Like you have your counter that comes from a quantum algorithm, right? And it keeps on going and then you do stuff based on that and you can continue. So you can code some really cool new kind of style of algorithms.
Okay. Yeah.
I mean, just my opinion, my 2 cents. Yeah.
Yeah, that's a cool idea.
Or you can speak with Bob Keck from Continuum, right? And why not do that? Discuss with him about gamifying ZX calculus, which is like this rigid graph-based representation of quantum dynamics, kind of like a competitor of Quantum Odyssey style, but for tensors, and make that a computer game. That's also a good idea. So like, there's a lot of graph theory stuff in quantum computing that's completely, it looks very trashy, right? Because it's just, yeah, PDFs.
Mm-hmm. Yeah. Thank you for all the ideas.
You're welcome. Anytime.
Great, fantastic. Do we have more questions? All right, so if there are some further questions, you can join the Discord and you can find Laura there. Laurentiu, would you maybe also like to share some other contacts, like email address, for example, or it's up to you, of course.
Yeah, I can give you the official Quarks Interactive that I always have open. So the contact at Quarks Interactive, whatever ideas you want, like I know you want to help us with some code or something, always send me any
Perfect.
official stuff.
Perfect. Thank you very much for this. Thanks for a great presentation. So I will now stop recording.